Good afternoon, ladies and gentlemen, and welcome back to Flawless 195. This is flight 97 of 210. It's Lilongwe to Harare in countries Malawi to Zimbabwe. Departure time is going to be about 2:30 p.m. local time, and the flight time is expected to be about 3/4 of an hour. We are heading southwest, I believe, on this flight. But yeah, 3/4 of an hour. I'll get the safety demo on now. What else to say? That is about it. We are heading for Harare International Airport, which is, I think, slightly south of Harare. And right now we are a few miles north of Lilongwe, but that's how it goes. You know, you can't be landing dead centre in the middle of these capital cities. Sometimes they don't have a runway, and if they do, sometimes it's a very small runway meant for smaller aircraft. But that being said, let's get it underway. Flight 97, the halfway mark is within sight now. And as we're in this south leg of South Africa, yeah, I think it literally goes Zimbabwe, Botswana, Namibia, then South Africa, then we start coming back up Lesotho, Eswatini, Mozambique, and then we get into the Madagascar, Mauritius, Seychelles leg, which is where we get the Dia TBM out. And I was thinking actually about this Dia TBM leg to the Seychelles and back. I'm going to have to do that in one day, in one go, because I can't land on a field in the Seychelles and then come out of the game, because I can't load up the plane in a field in the Seychelles. I can't start a flight there. So I have to just land it after like 3 hours and go, right, let's take off and go back again. So it's gonna be a full day, that. It's going to be a full day, and I'll just cut the video in the middle and say, right, join me in 30 seconds, end the video and start it again. Like when I do a helicopter leg. When I've done the helicopter legs, it's not like I'm loading up a helicopter on a helipad in Monaco. I just have to end that video, start the next one and take off again. It's going to have to be like that. So it might be like a 6-hour round trip in one stint. That's going to be a full day. And that's coming up pretty soon. That's coming up in the next fortnight. So yeah, what a day that's going to be. But like I said, I've always said, if I get back from the Seychelles, then it's on. If I get back and I touch down in North Madagascar in the Dia TBM and I've successfully done the Seychelles leg, then it's really on. We're over halfway and I've got a big obstacle out of the way. But anyway, let's get on with flight 97. I'm talking about flight 103 or something. This is flight 97, Malawi to Zimbabwe. Also, Lemino on YouTube has just dropped a 2.5 hour documentary. So I'm going to watch a bit of that. We're going to put a bit of that on. But it'll be split up probably into the next 3 or 4 flights, because yeah, 2 hours, 27 minutes. So the best YouTube channel in the world has just done a monster upload. Yeah, Shouting at the Stars, a history of interstellar messages. Oh, it's right up my street. Right, we're not going interstellar today. We just get up to 39,000 feet, cruise for 10 or 15 minutes, and back down we go. We haven't got ILS into Harare International Airport, but the flight path in lines up pretty well with the runway, so I don't have to do any mad deviations or anything. But yeah, pretty standard 3/4 of an hour flight. Let's get on with it. That's enough waffling. And where's this taxi going? He's giving up on it. He says, I'll see you later. Right, don't hit the back of the plane yet. Go around me. Go around me. Go around me. You're a bit close, mate. Right, let's get on with it. I'll speak to you when we are in the air. Bye for now. Let's get the safety demo on.
Illuminated signs and crew instructions, including the following safety procedures. The safety card found in your seat pocket contains important information about exit routes, oxygen masks, life jackets, and the brace position that you must adopt if you hear brace, brace. There are 8 emergency exits on this aircraft. The cabin crew are now pointing out the exits nearest to you. Please be aware that your nearest usable exit may be behind you. Emergency lighting will guide you to an exit. In an emergency, leave all baggage on board. Your seatbelt is fastened, adjusted, and released as shown. It must be fastened when the seatbelt signs are on, and we recommend that you keep it fastened at all times. If the air supply fails, masks will drop from above you. Pull a mask towards you to start the oxygen. Put the mask over your nose and mouth and breathe normally. Hold the mask in place with the strap. Pull on each side to adjust. Put on your own mask before helping others. If we land on water, take a life jacket from under your seat. Remove from the pouch and put it over your head. Pass the tapes around your waist and click together. Pull the strap to adjust. Do not inflate it inside the aircraft. When outside, inflate it by pulling the toggle. If it fails to inflate or needs topping up, blow into this tube. There is a light and whistle for attracting attention. The cabin crew can assist you with life jackets for children. Your tray table must now be stowed, armrests down, window blinds open, and seatbelt fastened. Further information regarding your safety on board can be found in the in-flight magazine. We hope you have a great flight.
Just let me know.
In early 1972, a probe known as Pioneer 10 was launched into space on a mission to the largest planet in the solar system. After millennia of speculation and wonder, humanity got its first close-up view of Jupiter. Accelerated by the immense gravity of the planet, Pioneer 10 was then catapulted into deep space, destined to leave the solar system and roam the galaxy for billions of years. On the off chance that this vestige of humanity should one day be intercepted by an alien intelligence, it was affixed with a message. A message designed to answer 3 central questions.
Where we are, when we are, and who we are.
More than half a century has now passed since the launch of our first galactic emissary, and in that time we've made numerous attempts to communicate with life beyond, either by attaching greeting cards to probes headed for interstellar space, or by targeting our cosmic neighbors with high-powered beams of light. So far, humanity's been left unread, but that could change at any moment. As long as we keep making noise, there's always a chance we'll be heard. An exceedingly slim chance, as we'll see, but a non-zero chance nonetheless. Given the paradigm-shifting potential of contacting beings from another world, it sure would be nice to know what exactly we've been telling them all these years. I mean, don't get me wrong, where we are, when we are, and who we are sounds really neat and all, but it's not exactly rich in detail. So let's start with that plaque on Pioneer 10. What does it say, and more importantly, to whom should I direct my anger when the aliens arrive to harvest my bones? The idea to attach a message to Pioneer 10 was the brainchild of journalist and author Eric Burgess. Less than 4 months before the probe was scheduled to launch, Burgess approached famed astronomer and science communicator Carl Sagan, who in turn relayed the proposal to NASA. Sagan was given 3 weeks to devise the message, and with the help of his wife and artist Linda, as well as fellow astronomer Frank Drake, they scrambled together a series of pictograms etched into a gold-laden plate of aluminum. In the words of Sagan, It is written in the only language we share with recipients, science. Near the upper left corner, we find a diagram of hydrogen, the simplest and most abundant element in the universe. One electron bound to a proton. More specifically, the diagram depicts a single atom of hydrogen transitioning from one energy state to another, which is meant to be conveyed by this horizontal line here in the middle. This shift in energy is known as a hyperfine transition, and it's accompanied by the emission of a radio wave. That radio wave has a very specific frequency that's so prominent across the universe that we've given it a name, the hydrogen line. Something that beings of sufficient intelligence to capture a drifting spacecraft would no doubt be aware of as well. In human terms, it has a frequency of about 1420 MHz, which means that each cycle of the wave has a period of about 0.7 nanoseconds and a corresponding length of roughly 21 centimeters. The recipients would obviously express their measurements using something other than nanoseconds and centimeters. But what's important here is that they're measuring the same thing and that thing never changes. The duration of one wave cycle and the distance covered during that cycle remains the same across the universe. This allows us to establish a shared unit of both time and length. We're basically telling the aliens to treat their measurement of the hyperfine transition of neutral hydrogen as one unit of time and one unit of length. That's why there's a vertical line here in the middle, which is meant to convey the concept of one in binary. But of course, hydrogen is merely one of many possible interpretations of this diagram. The aliens could just as easily think it's some sort of language, technology, star system, or literally anything else. To help them narrow down the list, the plaque includes 3 outline silhouettes of a man, a woman, and Pioneer 10. These illustrations were drawn to scale so the aliens can use the spacecraft's diameter as a basis for deriving the height of the 2 figures in the foreground. In human terms, that would make the man approximately 182 centimeters and the woman about 169. The woman's height has been further emphasized by 2 demarcation marks along the right edge here. Between them is a sequence of 4 lines representing the number 8 in binary. The purpose of this number is to communicate to the aliens that the woman is 8 times as tall as the wavelength of the hydrogen line. In human terms, that's about 169, just like the woman's height relative to the probe's diameter. In other words, the interpretation of this as a schematic of hydrogen and the interpretation of this as an outline of the spacecraft are mutually corroborative. They provide the aliens with a means of deriving the height of this figure on the basis of 2 distinct measurements.
Cabin crew seats for takeoff.
Which should help them narrow down the list of possible interpretations. At least, that was the idea. But when you actually measure the height of the couple relative to this sketch of the probe, you quickly realize they're about 10 centimeters too tall. While I have no way of confirming this, I suspect the source of this discrepancy is that the reflect edition Pioneer 10 is not the perfect circle. It's slightly wider in this dimension than in this one, known as a major and minor axis. If we assume that this outline of the probe is oriented with a minor axis along the vertical, the relative height of the couple is indeed what you'd expect. But if that is what the Sagans and Drake intended, only 2 of the 3 antenna struts should be visible here in the front. The fact that all 3 have been drawn on the plaque implies the probe is oriented with a major axis along the vertical, thereby increasing the couple's height by roughly 10 centimeters. Nevertheless, it's hardly surprising for an oversight like this to go unnoticed, given they only had 3 weeks to assemble everything, and Sagan acknowledged they could have done a better job had they not been so pressed for time. Moving on to the left side of the plaque, we find a starburst pattern of 15 straight lines emanating from a central point. This is a galactic map of pulsars that's meant to help the aliens pinpoint the solar system. Pulsars are rapidly rotating neutron stars that can easily be spotted from thousands or even millions of light years away. They're often described as cosmic clocks or lighthouses because they're not only extremely bright, but pulsate at very consistent rates. This red line shooting off to the right represents the distance between the Sun and the center of the galaxy, while the green lines represent the relative distance between the Sun and 14 pulsars. To make it easier to identify the pulsars, each line is accompanied by the star's rotation period expressed in binary, marked here in blue. Take this one for instance. This star is known as the Vela pulsar, and it's about 1,000 light years from Earth. Its rotation period has been expressed in wave periods of the hydrogen line and reads 126,726,823 when translated from binary to decimal. What that means is that it takes the Vela pulsar almost 127 million times longer to complete one rotation than the wave period of a hydrogen atom undergoing hyperfine transition. In human terms, that's about 89 million nanoseconds, or 11 rotations every second, which is about this fast. By scouring the galaxy for pulsars that match the information embedded within this map, the aliens could, theoretically, triangulate the solar system. In fact, the chart not only discloses our location in space, but also in time. As Sagan put it,
where we are, when we are, and who we are.
This goes back to the cosmic clock analogy because pulsars gradually wind down at highly predictable rates. So even though the Vela pulsar will have a much slower rate of spin by the time it's observed by our hypothetical aliens, they could simply wind back the clock until its rotation period matched the one etched into the plaque. Repeating that process for at least some of the other pulsars would enable them to figure out not just from where, but also when Pioneer 10 was launched. At least, that was the idea. But when the plaque was created, the existence of pulsars had only been known for about 4 years. Astronomers have since learned a lot more about them, and they're not nearly as rare, stable, and long-lived as once believed. They can only be observed from very specific vantage points, and unpredictable speed-ups, slowdowns, and glitches challenge the cosmic clock analogy. Sagan and Drake were aware of at least some of these issues, but there was only so much they could have foreseen with the limited data available at the time. In fact, there was such great uncertainty regarding the distance of some of the featured pulsars that they added these breaks in the lines, indicating they're based on rough estimates rather than exact figures. Finally, on the bottom of the plaque, we find a plain schematic of the solar system. These binary numbers represent the orbital distance of each planet, expressed as multiples of 1/10 of the mean distance between the Sun and Mercury. For instance, the number above Earth reads 26 in decimal, which means it is 26 times further away than 10% of the distance between the Sun and Mercury. The obvious problem with this approach is that it requires the recipients to already be familiar with the solar system. Otherwise, 1/10 of the distance between the Sun and Mercury is completely meaningless. We might as well expect them to be familiar with kilometers or miles. To quote the creators of the plaque, "There is no way for this unit of length to be deciphered in the message." It's unclear why the Sagans and Drake knowingly used an indecipherable unit of length when they had already gone through the trouble of creating a universal yardstick with the schematic of hydrogen. My best guess is that the wavelength of a state-shifting hydrogen atom was simply too small a unit to represent interplanetary distances, and the resulting binary strings became too long to neatly fit on the plaque. Again, they only had 3 weeks to do all of this. Last but not least, the trajectory of the spacecraft has been traced with an arrow, and the probe's main antenna is pointing it home. Over half a century later, Pioneer 10 is now more than 20 billion kilometers from the Sun. That might sound like a lot, especially given how I just emphasized that number, but it's only about 3 times further away than Pluto, and it takes less than a day for a light beam to cover the same distance. Even though it's darting through space at several kilometers per second, the probe won't surpass even the nearest star to the Sun for many tens of thousands of years. But it gets worse because Pioneer 10 is not headed for any particular star. It's expected to pass within a few trillion kilometers of a relatively nearby system in about 90,000 years or so, when this star, all the way out here, will come closer to the Sun than Proxima Centauri is today. While an exoplanet has yet to be detected around this star, if one does exist, and that planet just so happens to be inhabited by intelligent beings in possession of technology that allows them to detect a perfectly silent and practically invisible speck gently gliding by their system at a distance greater than 1,000 times the orbit of Pluto, then yeah, maybe they'll see it. A nearly identical probe was launched in 1973, known as Pioneer 11, and it was outfitted with the exact same plaque as Pioneer 10. Much like its predecessor, Pioneer 11 was just kind of hurtled into deep space with no particular target in mind. While a chance encounter with another planetary system is not impossible, even across timescales of many billions of years, Sagan and Drake believed it was more likely for the probes to be scooped up by an alien spaceship traveling between the stars. Some studies have shown that space is, in fact, a tiny bit big. It's very easy to criticize the Pioneer plaques. Any message designed to be understood by beings of which we know nothing about will unavoidably rely upon assumptions that could easily be false. Will the aliens understand the meaning of an arrow? Will they comprehend binary notation? Will they even grasp the concept of conveying information using two-dimensional pictograms? While questions like these are perfectly valid, they're ultimately quite pointless because the answer is always the same. We don't know. We don't know what the aliens look like, how they think, or even if they exist. The plaque could be so at odds with how they perceive and navigate the universe, they fail to even recognize it as a message. Or we might be foolish for thinking a civilization so technologically advanced they're able to locate and retrieve a derelict spacecraft from the dead of space will be stumped by an interstellar cave painting. While many believe the recipients will be nothing like us, we could just as easily have a lot in common. After all, we share the same universe and are therefore shaped and bound by the same physical laws of nature. In fact, that's what some people fear the most, that the aliens could be just like us, that they could inflict upon us what we inflict upon members of our own species. The Sagans and Drake tried to get ahead of these concerns by emphasizing the improbability of interception. They stressed that even if the probes were to fall into the tentacles of a hostile intelligence in some distant future, they'd be too far away to pose a threat. But statistics and probability only get you so far because fear is a powerful emotion.
And may I say, so that we can have a somewhat warmer and livelier conversation as this meeting goes on, I can conceive of no nightmare as terrifying as establishing such communication with the so-called superior, or if you wish, advanced technology in outer space.
A year after the launch of Pioneer 11, the Arecibo Radio Observatory, located deep within the jungles of Puerto Rico, received a major facelift. The telescope was not only resurfaced to greatly increase its sensitivity, but also outfitted with a powerful transmitter. As it happens, the man in charge of the research center overseeing the facility was none other than Frank Drake. To celebrate the telescope's upgraded capabilities, Drake's assistant, Jane Allen, suggested they transmit an interstellar message during the upcoming rededication ceremony. Unlike the tangible Pioneer plaques, the Arecibo message had to be communicated using invisible radio waves. Drake had previously experimented with the idea of transmitting an image coded in binary, and with the help of some colleagues and graduate students, he came up with this. Now, this may not look like much, but if we fill in all the zeros with black squares and all the ones with white squares, a highly pixelated image will emerge. I'll explain the different parts in just a moment, but first, it's important to understand how an image like this is converted into radio waves. It starts with a grid that in this case is 23 columns wide and 73 rows tall for a total of 1,679 cells. We then fill in the cells needed to create the image. Because the image is composed of only two shades, black and white, that means it's binary, and each cell can also be described as a binary digit, or bit for short. By convention, binary code is expressed using zeros and ones, but it works just as well with two different shapes, two different colors, two different rocks, or literally any combination of two contrasting values. In fact, that's why binary code is so frequently used to write interstellar messages. It's not because aliens are guaranteed to understand it. No, it's simply one of the least complicated methods of conveying information that we can imagine. Chinese is composed of thousands of characters, English has 26 letters, while decimal demands 10 unique numerals. Binary only requires 2. Not 2 letters, not 2 symbols, literally just 2 of something, which we call bits. For instance, instead of black and white squares, we could just as easily express this bitmap using 2 different frequencies. If a cell is black, that's one frequency. If it's white, that's another. There you go, that's all there's to it. This long sequence of 2 flip-flopping frequencies can now be transmitted using a radio telescope. When that signal is picked up by an alien astronomer, they may find it difficult to ascribe such an unnatural pattern to a natural source. This will hopefully draw attention to the number of frequency fluctuations because 1679 is what's known as a semi-prime. It's disappointingly not the half-brother of Optimus Prime, but rather the product of precisely 2 prime numbers. In this case, those prime numbers are 23 and 73, which happens to be the dimensions of the original grid. If the aliens were to plot the frequencies onto a grid of that size and fill in all the cells occupied by one of the values, they would uncover the image. As for the contents of the message, it starts off easy enough with the numbers 1 through 10 expressed in binary and written from right to left. So 001, 010, 011, and so on. Moving on to this large cluster of pixels, we find a bunch of binary formulations for the building blocks of life as we know it. It starts with the atomic numbers of 5 basic elements: hydrogen, carbon, nitrogen, oxygen, and phosphorus. These numbers are then used to describe essential components of DNA. For instance, a carbon atom has 6 protons, which means it has an atomic number of 6. 0110 is binary for decimal 6. Because carbon is in the second column from the right, it means the second column of these molecules underneath indicates how many carbon atoms they contain. So these 4 represent an organic compound known as deoxyribose, which has 5 carbon atoms, and 101 is binary for decimal 5. In the center of the image, we find a crude rendition of the DNA double helix enclosing a large binary value denoting the number of nucleotide base pairs in the human genome. In simpler terms, it's a way of expressing the complexity or size of our genetic makeup. However, more recent measurements have since reduced that number by over 1 billion, so this figure is no longer accurate. A bit further down, we find a simple sketch of a human alongside an expression of their height on the right and the estimated global population in 1974 on the left. Directly underneath the human is a schematic of the solar system, followed by an illustration of the Arecibo telescope. Now, you might be wondering, how the hell were the aliens supposed to understand any of that? The simple answer is, they weren't really. Unlike the Pioneer Plaque's commendable attempt to establish some sort of common ground using shared units of measurement and a galactic map of pulsars, the Arecibo message was much more of a publicity stunt. For instance, the length of the message was largely determined by the presumed attention span of those invited to the rededication ceremony. The concern was that if the message was too long, attendees might be annoyed by the sound of the transmission, which was planned to be broadcast over loudspeakers at the event. In the end, the message was constrained to about 3 minutes to mitigate the risk of a dull afternoon. Likewise, the selection of a target for the transmission was entirely dictated by what happened to be visible in the sky during the ceremony. Drake ultimately selected a bright cluster of stars known as Messier 13, which is about 24,000 light-years from Earth. While this meant the message would take 24,000 years to reach its destination, the density of M13 also meant the signal could sweep over many thousands of stars upon arrival. At the time, this was thought to maximize the odds of the transmission being received, and Carl Sagan even told a reporter that he believed there was a 50% chance that M13 was home to an alien civilization. But as it turns out, more stars does not necessarily mean more opportunities for life. Not only are globular clusters like M13 typically starved of heavier elements essential for planetary formation, but the proximity of the stars makes it challenging for any planets that do form to maintain stable orbits. Considering it took billions of years before humans evolved on Earth, a region as densely packed and chaotic as M13 is probably not the most conducive environment for life as we know it. While there is some optimism that small planets like Earth could survive in very tight orbits, out of 6,000 exoplanets discovered to date, only 2 are located within a globuluster. Nevertheless, on November 16, 1974, a small crowd of astronomers, dignitaries and others bopped along to a 3-minute concert of 2 warbling tones as humanity's first interstellar radio telegram was beamed into space. A common misconception about the Arecibo message is that it will miss its target because the telescope was aimed at the position of M13 at the time of transmission rather than where it will be in 24,000 years. In reality, when Drake crunched the numbers back in 1974, he realized that the cluster is so enormous and slow-moving that even if they aimed the telescope at its location at the time, the message would simply strike slightly off-center rather than a bullseye. Presuming against all odds that M13 is home to an alien civilization in possession of an extremely sensitive instrument that's not only designed to pick up radio waves at the exact same frequency and bandwidth at which the Arecibo message was transmitted, but also pointed squarely at the solar system at just the right time, Messarian astronomers will have a non-zero chance to detect a non-repeating burst of energy lasting for less than 3 minutes, some 24,000 years from now. Even though they're unlikely to decode the message, they might still suspect it's an attempt at communication. It's a bit like, even if you don't speak Swedish, så kan du fortfarande förstå att någon försöker kommunicera. If they suspect it's a transmission from another civilization, the aliens may choose to respond. Presuming there's no way to overcome the speed of light, such a response would obviously take just as long to reach us as it took the Arecibo message to reach them. Based on the most recent measurements of the distance between the solar system and M13, the earliest possible date we can expect a reply is the year 50,370. Don't forget to mark your calendars. There are even more hopelessly optimistic scenarios like a star or spaceship crossing paths with a signal somewhere along the way, but the odds of that happening are so vanishingly small it might as well be impossible. Not least of all because, as you can see, M13 is actually floating far above the galactic disk, and there's a whole lot of nothing in between. But once again, these astronomical improbabilities were not enough to allay concerns of an alien invasion. A prominent radio astronomer in Britain at the time, Sir Martin Ryle, feared the Arecibo message might attract a more advanced civilization seeking to colonize the Earth and mine its resources. He took issue with the fact that a small group of people had transmitted a message that could endanger all of humanity and called for an international discussion in advance of any future transmissions. While these concerns largely fell on deaf ears at the time, Ryle was far from the only one urging caution.
While the target star cluster in this instance is so far away that no reply would be received for 48,000 years, the temptation will be great to send more messages to closer stars. Have we really thought through the possible consequences of calling ourselves to the attention of a civilization superior to our own?
By the mid-1970s, NASA was gearing up to launch 2 spacecraft known as Voyager 1 and 2. Much like the Pioneer probes before them, the Voyager twins would be slingshot into deep space by Granddaddy Jupiter on their way to explore the outer solar system. Due to the similarity between the 2 programs and the public interest generated by the Pioneer plaques, NASA engineer John Cassani thought a similar message ought to be carried by the Voyagers. When Cassani reached out to Carl Sagan in late 1976, he jumped at the chance to scribe another cosmic postcard. But this time he wanted to impress upon the recipients not just how we think, but also how we feel. After consulting numerous people on how to proceed, 2 propositions stood above the rest: music and pictures. Sagan was partial to music, while fellow astronomer Frank Drake thought nothing could capture the human condition like a series of photographs. After some additional brainstorming, it was Drake who finally realized they could accommodate both ideas using a phonograph record. A phonograph record is an analog storage medium primarily used to record and replay sound. To record, you simply press a needle against the surface of a slow-spinning disc. By generating a sound like strumming a guitar, the needle will start to vibrate as it carves a thin, undulating groove into the disc. To replay the sound, you simply create a copy of the disc using a less malleable material, place the needle back at the beginning of the groove, and spin the disc back up again. As the needle collides with the hundreds of microscopic indentations in the groove, it generates the same vibrations used to create it. When those vibrations reach your ears, you'll hear a guitar being strummed. The process is a bit more complicated in practice, of course, but honestly, not by much. Whether it's a single vibrating guitar string or the deafening crescendo of an entire orchestra, all of it can be recorded and replayed by tiny bumps in a groove. Yes, magic is real, and this is it. But what about photographs? How do you get visual information onto a storage medium made for sound? It's surprisingly simple, actually. Remember how the Arecibo message painted a picture by treating black and white squares as two different frequencies? I mean, it would be a bit concerning if you don't. That was like 12 minutes ago. You better get that checked out. Anyway, they basically did that, but instead of just two frequencies, they used a whole range of them. Take a gradient like this, for instance. If we assign a low frequency to black and a high frequency to white, then every shade of gray in between will be mapped to a corresponding frequency of sound. With that translation scheme in mind, converting an entire photograph becomes trivial. For instance, this is a black and white image of Mercury that's actually on the record. All we have to do is scan every pixel in this image, one by one, column by column, and translate every shade of gray into its audible equivalent. Once we've translated every frequency of light into a frequency of sound, we end up with a brief sample of incoherent noise that acts like an acoustic fingerprint of the image. Again, I'm simplifying a lot here, and the actual process used analog signals rather than quantized pixel values, but it gives you a rough idea of how it was done. Some photographs were actually recorded 3 times in a row using filters for red, green, and blue. When recombined in just the right way, they produce an image full of vibrant colors, even though individually they're all black and white. Again, magic is real. In an effort to save space, they also recorded 2 simultaneous streams of images into the same groove. This was accomplished by using the side-to-side motion of the needle to record one stream and the up and down motion to record another. The end result was this echoey stereo sound of 2 image streams playing at once. To provide the aliens with the best possible chance of decoding this cryptic disc of gold-plated copper, the record's aluminum cover was engraved with some basic instructions. First of all, the pulsar map makes a return, and so too does the diagram showing the hyperfine transition of neutral hydrogen, the latter of which is once again used to establish a shared unit of both time and length. Near the top left, we find an overhead view of the record, circumscribed by a binary number. It's telling the aliens to spin the record about 5 billion times faster than the hyperfine transition period. In human terms, that's equivalent to roughly 1 rotation every 3.6 seconds. To ensure the aliens have something with which to play the record, a ceramic cartridge holding a diamond-tipped needle was attached to the mounting bracket. An outline of this cartridge has also been drawn along the right edge here to indicate the playback starting position. Underneath the overhead view, there's also a side view, accompanied by another binary number. This time, it's telling the aliens how long it takes to play one full side of the record, which is about 54 minutes. Moving on to the top right, we find a step-by-step guide for decoding the images. The waveform at the very top corresponds to 3 vertical slices of the record's first image, while the zigzag pattern underneath means the slices are meant to be stacked side by side, one after the other. As we already know, this angelic symphony of beeps and buzzings are mapped to different shades of grey according to a very specific translation scheme. A scheme the aliens are meant to reverse engineer with the help of these binary numbers. There are 3 slices labeled 1, 2, 3, and each one corresponds to roughly 8 milliseconds of audio. A full image is 512 slices wide and should form a rectangular shape with a 4:3 aspect ratio. Simple as that. On the off chance that the aliens should somehow be confused by these crystal clear instructions, the record's first image has also been outlined here at the bottom to show them what it's supposed to look like when properly decoded. In fact, this calibration circle is the very first piece of data the aliens would find on the record. It's followed by more than 100 images, starting with some basic math, units of measurement, and a speedrun of the human experience. The sequence ends with this image of a violin floating above a page of musical notation. It shows the beginning of a somber classical piece known as cavatina, and once the image fades, legendary MC Ludwig von Beethoven kicks off the mixtape. But the minutes-long performance of Cavatina only plays for a few seconds before it's interrupted by even more beeps and buzzings. You see, 6 additional images were squeezed onto the record at the very last moment, including a written statement by then President of the United States, Jimmy Carter, and a tedious listing of nearly 100 members of Congress. This bureaucratic theme then segues back into audio with a speech by then Secretary General of the United Nations, Kurt Waldheim.
As the Secretary General of the United Nations, an organization of 147 member states who represent almost all of the human inhabitants of the planet Earth, I send greetings on behalf of the people of our planet. We step out of our solar system into the universe seeking only peace and friendship, to teach if we are called upon, to be taught if we are fortunate. We know full well that our planet and all its inhabitants are but a small part of this immense universe that surrounds us, and it is with humility and hope that we take this step.
The aliens will then be treated to a series of greetings spoken in 58 different languages.
Konnichiwa, o genki desu ka?
Siyanibingelela maqhawe, sinifisela inkonzo ende.
Hälsningar från en dataprogrammerare i den lilla universitetsstaden Ithaka på planeten Jorden.
Silema Jemen.
धरती के वासियों की ओर से नमस्कार.
Hola y saludos a todos.
تحياتنا للأصدقاء في النجوم. يا ليت يجمعنا الزمان.
Shalom.
Salvete quicumque estis. Bonam erga vos voluntatem habemus, et pacem per astra ferimus.
各位都好吧，我们都很想念你们，有空请到这儿来玩。
Пересилаємо привіт із нашого світу, бажаємо щастя, здоров'я і многое літа.
Hello from the children of planet Earth.
This is followed by various sounds of things like weather, animals, and technology, before the record ends with a playlist of nearly 90 minutes of music covering a vast array of instruments, styles, and cultures. It starts about halfway through the A side of the record with an uplifting composition by Johann Bach. After another 9 tracks, including a famous American rock single and many obscure folk songs from around the world, the music picks up again on the record's B-side with another banger by Johann Bach. After nearly an hour's worth of additional music from countries like Germany, Peru, Russia, China, and India, just to name a few, the golden record comes to a significant end with a full rendition of Beethoven's Cavatina. Nearly half a century later, Voyager 1 is now the most distant spacecraft ever launched. Even though it was preceded by the Pioneer probes by several years, and even its own twin by 2 weeks, Voyager 1 attained a greater escape velocity and in a sense overtaken them all. Amazingly, both Voyagers are still transmitting to this day, although they're fast approaching their operational limits. Once they go offline and fall out of range, they'll join their pioneering brethren in a timeless and destinationless trek between the stars. Because the interstellar medium is sparsely populated with tiny dust particles, the exposed surfaces of both the Pioneer plaques and the golden records will erode over time. While the former is somewhat protected by its inward-facing placement, it's still exposed to the vacuum of space. On the other hand, the golden records are firmly pressed up against the body of the spacecraft. According to one estimate, the outward-facing B-side could survive for at least a few billion years, whereas the lifespan of the concealed A-side is anyone's guess. It's not impossible that many tens or even hundreds of billions of years from now, all the photographs, greetings, and 1/3 of the music will still be intact. While the response to the golden records was overwhelmingly positive, they did nonetheless receive a bit of criticism. Much like before, some people were completely undeterred by the near impossibility of interception and feared the Voyagers might attract a hostile intelligence. Others focused more on the contents of the message because they felt it was disingenuous to paint humanity in such a positive light when war, crime, and cruelty are as much a part of the human condition as music, sports, and science. As one of the makers of the record, John Lomberg, so succinctly points out,
"More human beings have killed one another or starved to death than have written string quartets."
The decision to exclude the uglier sides of humanity was partly to avoid potential backlash from people here on Earth, but also an attempt to make us seem less hostile to any future recipients. While a mushroom cloud does convey a shameful yet significant part of who we are, it could also be perceived as a threat. On the other hand, the exclusion of such imagery could by itself be quite revealing as we expose our casual willingness to deceive through tactful omission. Dating profiles, job interviews, meeting someone for the first time. I don't know if this is what the Golden Records team had in mind, but being selective with the truth to make a good first impression, how terribly human of them. The 3 initiatives mentioned so far are likely to be the only ones you've heard of before. The Pioneer plaques, the Arecibo message, and especially the Golden Records generated immense public interest at the time and remain well known to this day. But our attempts to communicate with life beyond did not end with the Golden Records. In fact, just a few years later, the silence was broken yet again, and this time the target was so close, the minimum response time was measured not in eons, but decades. In early 1983, Japanese publishing company Shueisha was looking for ways to commemorate the 15th anniversary of their most popular manga anthology magazine known as Weekly Shonen Jump. Due to the recent success of the film E.T. by Steven Spielberg and the fact that 1983 had been declared the World Communications Year by the United Nations, they decided to launch a competition dubbed Call to the Cosmos. The prize was a trip across the Pacific to visit a large radio telescope in Stanford, California, from which a message would be transmitted to a nearby star system. To win, all you had to do was submit a proposal for what the message should say. With a readership in the millions, the magazine received nearly 50,000 message ideas from children across the country. These were then compiled into one abbreviated message, and 15 lucky winners were selected to tag along on the trip. For the selection of a transmission target, the organizers turned to two radio astronomers named Masaki Morimoto and Hisashi Hirabayashi. They eventually chose the star Altair because it's very bright and relatively close. It was also selected because the message was planned to be transmitted during an annual Japanese festival known as Tanabata, which celebrates the meeting of two celestial deities represented by the stars Vega and Altair. Furthermore, Morimoto and Hirabayashi were asked to create their own message, and after 3 days of work, they came up with this: a sequence of 13 bitmaps measuring 71 by 71 pixels that were clearly inspired by the Arecibo message. The first 4 images depict things like natural numbers, prime numbers, basic math, common elements, the solar system, and essential building blocks of DNA. The next 8 illustrate the evolution of life from simple organisms to jellyfish, fish, amphibians, dinosaurs, apparently not Bigfoot, a family of humans, and a close-up of a woman's face. The final bitmap depicts a crude illustration of the Stanford radio telescope alongside information like its radius, wavelength of the transmission, and total number of bits in the message. We also find the word toast written in plain English. According to Hirabayashi, during the 3-day stint when he and Morimoto conceived of these images, they weren't necessarily sober the whole way through. This may or may not have influenced their decision to include the Japanese and English word for toast, equated to the chemical formula for ethanol. Because Weekly Shonen Jump targets a very young demographic, the magazine tried to clean this up a bit by reframing what was clearly an afterthought by two half-drunk astronomers as
a toast between Japan and the United States.
Nevertheless, for about an hour on August 15, 1983, the 13 bitmaps and an audio recording of the abridged fan-submitted greetings were beamed towards Altair.
こんにちは、こんにちは、こんにちは。こちらは太陽系第3番目の惑星、地球です。この電波は青い宇宙船地球号からまだ会ったことのない友達、E.T. のあなたたちへ平和と友好の願いを込めて送信されました。この計画をして日本という国の多くの子どもたちからメッセージが寄せられました。私たちの地球はもうすぐ新しい世紀を迎えます。その21世紀にはあなたたちと会えるかもしれません。だからさようならは言いません。もう一度友情の挨拶を送ります。こんにちは、こんにちは、こんにちは。
Altair is among the brightest stars in the night sky, and at a distance of less than 17 light-years, it's only, a few quadrillion stone throws away? In fact, Altair is so cosmically close that enough time has now passed for the transmission to have made a full round trip. That is to say, the message reached Altair back around the millennium shift, and we could have received the reply as early as 2017. Now, the fact that we never did does not necessarily mean there's nobody home. Perhaps they missed the brief 60-minute window when the message swept across their system. Perhaps they did pick it up, but they're still drafting a response. Perhaps they took one quick look at Earth and humanity and were like, nah, we're good. While all of these scenarios are of course equally probable, the most equal is unfortunately the first one. Not only have astronomers failed to detect a planet around Altair, but even if one does exist, the star's only been around for about 100 million years. Compare that to a 4.6 billion year veteran like the Sun, and things start to look a bit bleak. Sure, there's always the possibility that intelligent life typically evolves much faster than it did here on Earth, but we currently have no good reason to think that's the case. But it gets worse because even if the Altairians did respond, the odds of us even noticing are extremely remote, because telescopes are expensive, in low supply, and high demand. Sacrificing years, months, or even just days worth of observation time to screen a single planetless star for alien signals ain't exactly top priority. It wasn't until the summer of 2023 that a team led by astronomer Shinya Narasawa secured a brief time slot at the Yasuda Deep Space Center in Japan to search for a belated response to the Altair message. Scheduled once again to coincide with the annual Tanabata Festival, the search began late in the evening on August the 22nd and lasted for a grand total of 60 minutes. Remaining optimistic, Narasawa told reporters the following morning that they wouldn't immediately know if an alien signal had been detected because it would take a long time to analyze the terabytes of collected data. But given the lack of updates since then, I wouldn't keep my hopes up on this one. If nothing else, the message to Altair was received loud and clear by thousands of children across Japan. In fact, Call to the Cosmos seems to have had a bit of a rippling effect because a whole series of messages designed by Japanese children would later be transmitted for several years in a row. But before we get to all of that, we're going to take a brief detour into the dazzling world of censorship. As mentioned before, when the public became aware that NASA had bolted a plaque to the side of Pioneer 10, not everyone approved. But it wasn't just about the risk of attracting dangerous aliens, it was also about modesty. You see, some people were absolutely mortified to learn that the plaques featured line drawings of two naked humans engaged in the scandalous act of standing there.
I must say, I was shocked by the blatant display of both male and female sex organs on the front page of the Los Angeles Times. Surely, this type of sexual exploitation is below the standards our community has come to expect from the Times. Isn't it bad enough that we must tolerate the bombardment of pornography through the media of film and smut magazines? Isn't it bad enough that our own space agency officials have found it necessary to spread this filth even beyond our own solar system?
As amusing as that is, the controversy surrounding the plaque's nudity has been somewhat exaggerated over the years. These puritanical takes were muted and few, to quote Carl Sagan, and it's genuinely difficult to find examples like the one you just heard. There were a handful of reductive headlines, and some newspapers opted for the Barbie and Ken doll treatment, but the vast majority published the full, uncensored image and barely even mentioned the couple. In fact, some criticized the plaques not for showing the human form, but for not showing enough. More specifically, people took issue with the complete absence of visible female genitalia, considering that no such neutering had been applied to the man. It's unclear if the lack of anatomical detail on the lower half of the woman was demanded by prudish NASA officials or a decision made by the Sagans themselves. Conflicting accounts makes it difficult to know exactly who's to blame. Nevertheless, when it came time to select material for the Golden Records a few years later, these concerns flared up again. Fearing a repeat of the previous debacle, NASA religiously vetted every song, soundbite, and image that Sagan and co sought to include. They ultimately rejected a nude photograph of a young man and pregnant woman intended to show both human anatomy and procreation. The reason I'm bringing this up is because in 1986, an American artist by the name of Joe Davis decided to fight back against all this pearl-clutching with a project known as Poetica Vaginal. With the help of a few ballerinas and other volunteers, Davis used a custom-made device to record, how do I put this, contractions from within the female reproductive system. Those pressure oscillations were then artistically manipulated to create something that's meant to resemble human speech. After obtaining access to a radio telescope near the
Right, anyway, we're landing the plane. Cabin crew cease for landing. Right, I'm going to pause.
However, the broadcast only lasted for about 15.
Right, let's get it down. That went a bit weird, didn't it? Who let a pervert send a message into space is my next question. Anyway, right, let's get this down. Line her up. Okay. feels a bit quick, this, doesn't it? But it's not. Oh, God. Oh, it's a nice touchdown in the end. That's one of the better touchdowns that I've had. Gonna have to go a bit further down the runway though. Right, let's aim for that there. Let's aim for this here. Good. We're down. Yeah, let's go. This is not really a taxi on, it's more of a, not really a taxi off, it's more of a taxi on spot, but listen, we don't abide by them rules. There's somewhere to get off the runway, we're getting off. Right, where are we going? Guess we're going this way. But yeah, I was enjoying that. Got a bit weird there towards the end. But it's good. A lot I didn't know. But the final consensus is welcome to Harare, Zimbabwe. Flight 97 of 210 is complete. We're down. Nice soft touchdown as well. Descent wasn't too bad. Yeah, not much to say really. Standard flight. Nothing really crazy about it. We're being blown around quite a lot in the first quarter of an hour, so I left the seatbelt signs on for that reason. I don't know if I switched the lights on, did I, or anything, or put the seatbelt signs back on. But anyway, the point is we are down safely, and that is Malawi to Zimbabwe done. We are 2 hours ahead of the UK, so the local time is 3:25 in the afternoon, and the outside air temperature is 31 degrees. Please do drop me a like and hit the bell icon to receive all notifications on future flights of the Flawless 195 World Tour. I will continue the documentary in the next couple of flights because, like I say, it's 2.5 hours, so it's at least another 2 flights worth, maybe 3, of this Lemino video, which I'm thoroughly enjoying. Where are we going to park up? Let's go. Should we go up there? Where's he going with this tanker? I want to go up there. I want to go to one of them. Oh God, we're in a collision course here. You have to stop. Cheers, bro. Right, you're gonna have to stop as well. Oh, he's gone. Oh, we're going for it. We'll go this way. See, there's enough airport vehicles, isn't there? Jesus. Oh, bloody Pac-Man running from the ghosts. Right, let's get up here, get parked up, and yeah, we'll carry on the documentary next time. Next flight up will be to Gaborone, Botswana. So that is our next destination. Goes Botswana and then Namibia before heading to South Africa. Okay, let's go idle throttles and park her up here, and that will do us. I know they were probably waiting for me in the next gate there. Got everything set up and I've just slung it here, but there you go. We are down. We are at gate in Harare International Airport. You can take your seatbelts off and we'll see how long. It did predict about 50 minutes for the flight. I reckon we're about bang on. Let's have a look. Wow, look at that. Quick, mate. Let's get that off the screen in a minute. But yeah, there we go then. FWKI to FVHA, 46 minutes and 5 seconds. And that was because of the descent. I just headed directly for the runway and then just turned a bit at the end. Like, I didn't need to go massively off course. I didn't go off course at all. It basically just swung it in last minute, and that worked. Treat. like I say, the flight plan was taking us pretty much directly in line with the runway anyway, so it wasn't like I needed to do a massive deviation. So there we go, 46 minutes, and we are down. Malawi to Zimbabwe is done. Join me next time for Zimbabwe to Botswana. But that is all from me, Captain Wilson. This is Flawless 195, and you know the score. The World Tour continues. Join me next time. Thank you very much, and bring on the halfway point in this World Tour. Thank you very much. Flight 97 is complete. World Tour continues. Thank you very much. See you next time.